Okay, so last time we went through some examples to kind of drive home this point of domain of a function and what it means. Uh, and so, again, what we have come to is this idea right here that we're going to answer questions, ask questions, and answer them. Uh, Good habit to get into in mathematics. When you're doing problems, ask yourself questions and come up with an answer. Uh, so, uh, do we have a denominator? Then we solve an equation. Set the denominator equal to 0. Do we have even roots? Square roots, fourth roots, but most of the time it'd be square roots. If so, we take the stuff inside the radical and solve the inequality greater than or equal to 0. If we answer no to both questions, then quite simply the domain is everything, all real numbers. Okay. Got to get this problem in the point of view of asking questions. Hey, can't just say, oh, it's a domain problem, so I'll always do this. Because you don't always do this. Uh, but what you do is go through a set of questions. Now, later in the course, we'll add some other functions to our list, particularly logarithms. If you go on and take our pre-calc 2 class, you will find yourself dealing with domain and range or domain of trig functions. They each have their own limitations to kind of expand this list of functions. Okay, so let's look at some problems where we're trying to find the domain now. So let's begin with f of x equals 5x minus 12 over x squared minus 4. So we go through our checklist. Do we have a denominator? Yes, we do. So we need to exclude the things that make the denominator 0. So we solve the equation. Denominator equals 0. And we use whatever techniques we need to use to solve that particular equation. In this case, it's pretty straightforward, right? Bring the 4 to the other side, apply our square root. Remember, when we apply square root, that it's plus or minus. So square root of 4 would be 2, so plus or minus 2 equals x. Those are the things that make the denominator equal to 0. So when it then comes to the domain, here, domain of f, we would say x cannot be plus or minus 2. And if you're allowed to use that notation, that's all you have to do. And if you're going to be asked uh, till they finished beating the dead horse to write these in interval notation. There's reasons for it. It's a little bit of a pain in the butt. I'll admit. I don't like it myself for this kind of a problem. Uh, but it's helping you to get this interval notation idea down. You see it enough that it starts to click because you will be seeing stuff in interval notation from here on out forever. So very often these problems will ask you to write the answer in interval notation. So my advice with interval notation is just go to a number line. Right? Go to a number line and graph the inequalities that you have. Which in this case we can't be negative 2. We can't be 2. I'm allowed to be anything else though. So I can be anything there, anything in between, anything above. Right? And then we just take and write that down now as our interval notation. So that would be the interval here from negative infinity up to negative 2, not including it, union negative 2 to 2, union 2 to infinity. So that would be the interval notation, and that would typically be the answer for a lot of your homework questions, writing the problem out like that. Now, again, that's typically what you're going to run into homework-wise, is they're going to be given problems like that. Honestly, I prefer the much simpler, very clear notation here myself if I had a choice. But I understand, of course, why the book's wanting you to use this interval notation over and over again, just kind of to get it nailed down for you. Okay, so that's what you're going to be looking for the book. If you were doing a problem like this on a test, though, I would be, unless the directions tell you otherwise, I would be fine with you writing it out like this.